This weapon has turned the mathematics of war into a nightmare for air defense. A drone assembled from civilian market components that forces the expenditure of million-dollar missiles for its destruction. The Shahed 136 is a classic loitering munition built on a flying wing design. Its construction is stripped down for mass production. A carbon fiber airframe, a gasoline engine essentially from a lawnmower, and navigation based on civilian coordinates. It is not designed to be invisible or supersonic. Its mission is to overwhelm enemy air defenses through sheer numbers, operating as part of a swarm where losing 90% of the craft is still considered a success if the remainder reach their target. Strategic attrition. The secret to its effectiveness lies not in high technology, but in extreme cost efficiency, allowing it to be used as a strategic scale consumable. Shahed designers deliberately abandoned military standards, replacing them with consumer electronics and civilian motors to bypass sanctions. Hardware. Inside the drone, one can find processors used in household appliances and simple servos. This is a calculated choice. This configuration makes production independent of high-tech chip supplies and keeps costs down to a few tens of $1,000s. Economic trap. While an anti-aircraft missile costs anywhere from $100,000 to several million, the Shahed wins the war of budgetary attrition before it even explodes on target. The flying moped engine. To ensure this craft could fly 2,000 kilometers, it needed a simple and resilient engine. The characteristic sound that earned it the nickname moped is produced by a 50-horsepower four-cylinder engine, a copy of the German Limbach aircraft motor. The MD550 is a two-stroke air-cooled engine. It is extremely low maintenance and runs on standard high-octane gasoline. Despite its noise, the motor provides a stable speed of 150 to 180 kilometers per hour over 10 to 12 hours of flight. This decades-old design allows these engines to be assembled at any mechanical plant without the need for complex casting or precision machinery. Navigation and electronic warfare. While its low speed makes it an easy target for machine guns, navigation by stars and satellites becomes its primary ally at night. Modern versions are equipped with comator interference-resistant antennas, allowing them to ignore EW, electronic warfare systems, attempting to jam GPS signals. Early Shaheds relied on simple GPS/GLONASS chips and would veer off course if the signal was lost. However, the latest models, 2024 to 2026, feature digital antenna arrays. The system filters out interference and hears satellites even under active electronic suppression. Additionally, the drone carries an inertial navigation system. If satellite communication fails entirely, it continues its flight toward the target using an internal gyroscope. Payload and lethality. The drone completes its long journey for one purpose: delivering a 50-kilogram gift housed in its nose. Power. A warhead weighing up to 50 kilograms is comparable in power to a heavy 152mm shell, allowing the drone to destroy warehouses and breach building floors. Versatility. Depending on the mission, the Geron 2, the Shahed's local designation, can be equipped with thermobaric warheads for clearing personnel and equipment in bunkers, or high-explosive fragmentation/heat charges. Because it flies directly to coordinates, the entire explosive energy is concentrated on a specific point, making it more effective than unguided MLRS fire. Stealth through simplicity. The carbon fiber and foam construction helps the payload reach its target by remaining a ghost to certain types of radar. Materials. These materials reflect radio waves poorly. Radars tuned to detect large steel aircraft often mistake a Shahed for a large bird or weather noise. RCS. Metal is present only in the engine and the warhead, significantly reducing the radar cross-section, RCS, of the craft. Deployment and swarm tactics. To launch such a machine without an airfield, designers utilized a rocket-assisted start. The Shahed doesn't need a runway. It launches from an inclined rail using a solid fuel booster that jettisons seconds after takeoff. Mobility. Launchers can be mounted on standard trucks disguised as civilian freight trailers. A truck arrives at a position, fires a volley, and leaves before the drones are even detected in the air. Saturation. Drones are launched in groups of 10 to 30 to physically exhaust the number of ready-to-fire missiles in enemy batteries. Once the missiles run out, the remaining drones hit their targets unopposed. Advanced flight and 2025 upgrades. The Shahed flies at altitudes between 60 and 150 meters, using terrain and riverbeds to hide from radars behind the horizon. This ultra-low altitude flight protects it from long-range SAM systems. Operators pre-program waypoints so the craft zigzags around known defensive positions. In 2025 versions, the drone has ceased to be a blind projectile. Modern modifications are equipped with inexpensive video cameras and communication modems, including the use of civilian 4G networks, transmitting a real-time feedback to the operator. This transforms the kamikaze drone into a scout. If the target has moved or proves to be a decoy, the operator can redirect the drone to another object within its range. Furthermore, video footage of the impact is used for battle damage assessment and analyzing attack efficiency. By utilizing local SIM cards, the drone can transmit data through standard cellular towers, masking military traffic as civilian data. Such versatility has allowed the Shahed 136 to become a long arm for armies with limited budgets. The end of the missile monopoly. The Shahed has proven that a sanctioned nation can create strategic weaponry using technologies available in online stores, shifting the balance of power in regional conflicts. The success of this drone in Yemen against Saudi refineries and in the current conflict in Eastern Europe has demonstrated the futility of export controls over civilian components. Today, any nation or group with a minimal engineering base can create an analog to the Giran. This marks the end of the era where expensive cruise missiles held a monopoly. Now, precision strikes are accessible to everyone. Vulnerabilities and mass tactics. However, mass production comes at the cost of low survivability against anti-aircraft artillery. The countermeasure. The primary enemy of the Shahed is not the Patriot missile, but simple anti-aircraft guns like the Gepard or mobile hunting groups equipped with heavy machine guns. Detection. Due to its low speed and noisy engine, the drone is easily detected by acoustic sensors. Anti-aircraft artillery equipped with thermal imagers can shoot them down with high efficiency, spending mere pennies on shells. The numbers game. The core problem remains that there are always more Gerans than there are flak guns. They can attack from any direction, forcing the adversary to stretch their defenses across thousands of kilometers. A foundation for the future. Despite these vulnerabilities, this drone has become the foundation for an entire family of new aerial vehicles. Evolution. Based on the 136 model jet-powered versions, Shahed 238, and mothership drones, which carry smaller reconnaissance units, are already being developed. Scale. The Shahed 136 was the starting point. The transition to jet engines increases speed threefold, slashing the reaction time for air defenses. Meanwhile, the installation of new guidance systems is evolving the drone into a full-fledged cruise missile. Production in the Russian Federation, Geran 2, has been localized and scaled using automated lines, cementing this type of weapon as a primary instrument of warfare for the coming decade. The future belongs not to the most complex machines, but to the most mass-produced ones.